Okay, um, thanks for watching again. Part 2 here. There's one important formula and one important property of logarithms that we need to explore. So far we've only been able to evaluate common logarithms, which are log base 10, or natural logarithms, log base e, on your calculator. And if we wanted to evaluate anything other than that, we're stuck. For example, jump down to the bottom of your screen, find the value of log base 3 of 5 to the nearest 10,000th. You can't type that into your calculator. Your calculator won't evaluate a log base 3. We could change it to exponential form and say, okay, well, log base 3 of 5 is the exponent I should put on a 3 in order to arrive at 5, but we really don't have any way of figuring that out either, so we'd be stuck. So we use something called the change of base formula, and I won't show you where the formula comes from. We'll probably do that on Monday. But in general, this is a fact that you need to know. If you want to change the base of a logarithm, you can rewrite log with a base of b of x as log base a of x over log base a of b. That is to say, you can split the b and x up, in a sense, into two different logarithms using whatever base you want for a. But it does have to be the same logarithm. Now, usually, just to make life easy, we let a be either 10 or e. So in other words, we rewrite this as common log of x over the common log of b, or natural log of x over the natural log of b. So here's how we'd use that. Let's go down to the bottom and calculate what log base 3 of 5 is. Until now, we've had no way to do that. So we'll use the common log, that is to say base 10, so we don't even have to write the base on the logarithm. So log base 3 of 5 could be expressed as common log of 5 over common log of 3. Your calculator does have the ability to calculate each of those, so log base 3 of 5 would be log 5 over log 3. Your calculator, you can double check that. Log of 5 is 0.69897 over log 3, 0.47712. Divide those and we get 1.4650. So, there. We did it. Even though we can't evaluate that unconventional log directly, we use the change of base formula and compute it that way. Now, of course, we should check that, right? We should actually verify that it works. We should verify that 1.4650 is the exponent that we'd apply to a 3 or put on 3 in order to get 5. So take your calculator, take a base of 3, raise that to the 1.4650 power, and you better get 5, and you do. So it worked. We found log base 3 of 5, the exponent that goes on 3 to arrive at 5. Let's do one more. Let's calculate what the value of log base 11 of 70 is. Again, no way to do that on your calculator, so we rewrite it. Again, we'll use common log. I'd recommend trying this as well, just using the natural log. Even though the middle steps will look different, you'll still get the same value in the end. So log base 11 of 70, that's common log of 70 divided by common log of 11. Use your calculator, since your calculator does just fine with the common logs. Divide log 70 by log 11. You could do that in one step on most calculators, and you get 1.7118. There. We're done. We answered the question. But I know you're curious, so you should check. So let's take 11 and raise it to the 1.7718 power and find out, is that the exponent that we apply to 11 to get 70? Well, type that in. 11 exponent 1.7718. And sure enough, you get 70. Now we're a hair off here because we rounded that logarithm off a little, but you can see it's very, very close. So we found our logarithm. Okay, that's a simple little formula, but make sure that you know what that formula, the base change formula. I'll review that with you first thing on Monday, but that's one of the formula that you'll need to know for our last test here in a couple weeks. Okay, that's it. There was a few other small examples that I had in the notes, but I'm going to bypass those. I think we've thoroughly covered everything in the lesson. You should be able to complete your homework. So have a good weekend, and we'll see you on Monday.